Good morning, students. So, welcome back to the revision class. So, in the last class, we stopped at the question number 17, right? So, today starts from question number 18, right? So, what is transformer? Mentioned two sources of energy loss in the transformer, right? So, transformer is a device which is used to change the voltage, right? So either to increase or to decrease the voltage. So right, so what is transformer? Transformer is a device which is used to increase or decrease the voltage, right? So the next is mention the two sources of energy loss in the transformer, right? So losses in the transformer, right? So it is a device used to increase or decrease the voltage and as well as current. So current ಮತ್ತೆ voltage ಎರಡನ್ನೂ ಕೂಡ ನಾವು increase ಅಥವಾ decrease ಮಾಡಬಹುದು. The special is that is the AC voltage, right? To increase or decrease the AC voltage, right? So energy loss in the transformer. So reasons for the energy loss in the first one is copper loss, and the second one is due to flux leakage. So 3 marks only the losses you need to write the 3 points, right? So copper loss, flux leakage, then eddy current, and the last one is hysteresis loss, right? So these are the reasons for the losses in the transformer, right? That is sources. So move on to the next question. 19th question. Explain briefly the coil and magnet experiment to demonstrate the electromagnetic induction. That is coil and magnet experiment, right? So for the coil and magnet experiment, first we need to consider one coil, right? So this is the coil. This coil is connected to the galvanometer, right? So consider a coil. So coil is connected to the galvanometer, and consider one bar magnet, so which having the north pole and south pole, right? So explanation of the coil and magnet experiment, right? So when the magnet is moved towards the coil, right? So magnet no coil ಅಥವಾ ಮೂವ್ ಮಾಡ್ತಾ ಇದ್ರೆ, so magnet produces the magnetic field line. So those field lines, magnetic field lines, cuts the conductor, that is change in magnetic field. So change in magnetic field ಅಲ್ಲಿ ಯಾವುದಾದರೂ conductor ನ place ಮಾಡಿದ್ರೆ, so in that conductor the current is induced, right? So when the magnet is moved towards the coil, then the galvanometer shows the deflection, right? So when the magnet is moved away from the coil, then the galvanometer shows the opposite deflection, right? So that is the first point in coil and magnet experiment, right? So when magnet is moved towards the coil, galvanometer shows the deflection, right? So galvanometer it shows the deflection, right? So when it is moving towards the coil, right? So similarly, when magnet is moved away from the coil, galvanometer shows deflection in opposite direction. So galvanometer ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಂತ ತೋರಿಸುತ್ತೆ? ಇನಿಷಿಯಲಿ ರೈಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸ್ತಾ ಇತ್ತು ಅಂದ್ರೆ when it is moved away from the coil. So moved away from the coil ಗೆ dotted lines represent ಮಾಡ್ಕೊಂತಾ ಇದೀನಿ. So galvanometer deflection ತೋರಿಸ್ತಾ ಇರೋದು opposite direction. So that is also indicated by the dotted lines. So ಒಂದೇ ನೀಡಲ್ ಇರುತ್ತೆ, opposite deflection ತೋರಿಸುತ್ತೆ, right? So the second point is either the coil is stationary and the magnet is stationary. So eradu stationary agittu andre the galvanometer will shows no deflection. So both the coil and magnet are in stationary, then the galvanometer shows zero deflection. Similarly, when coil and magnet moving in the same direction, so coil and the magnet eradu in the same direction or move agta ittu andre then also the galvanometer shows zero deflection, right? So that is the second point, right? Coil and that is stationary coil and magnet or moving coil and magnet shows no deflection in galvanometer, right? So coil move ಆಗ್ತಾ ಇದ್ದು ಜೊತೆಗೆ magnet move ಆಗ್ತಾ ಇದ್ದು ನಮಗೆ galvanometer ಅಲ್ಲಿ deflection ತೋರಿಸೋದಿಲ್ಲ. So coil ಸ್ಟೇಷನ್ ಇದ್ದು magnet ಕೂಡ ಸ್ಟೇಷನರಿ ಇದ್ರೂ ಕೂಡ ನಮಗೆ deflection ತೋರಿಸೋದಿಲ್ಲ, right? So that is the second point. So 3 marks ಇರೋದ್ರಿಂದ we need to write the 3 points, right? The point is when magnet is moved fast, when magnet is moved fast, then galvanometer shows more deflection. So that is the third point. So this is about the coil and magnet experiment. So coil and magnet experiment ke ee diagram irbeku, jotege we need to write the 3 points. So the first point is when the magnet is moved towards the coil, galvanometer shows the deflection. When the magnet is moved away from the coil, then the galvanometer shows the deflection in the opposite direction, right? So that is the first point. So second point is both the coil and magnet are in stationary or both the coil and magnet are in moving in a same direction. So coil move ಆಗ್ತಾ ಇರೋ direction ಮತ್ತೆ magnet move ಆಗ್ತಾ ಇರೋ direction ಎರಡು in the same direction ಇತ್ತು ಅಂದ್ರೆ then also the galvanometer shows zero deflection or no deflection, right? So that is the second point. So third point is how much fast you are moving the magnet towards the coil or away from the coil, then the galvanometer shows the more deflection. So deflection ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಯಾವಾಗ ಜಾಸ್ತಿ ಆಗುತ್ತೆ? That is the magnet which is moving fast. So ನಾವು ಎಷ್ಟು ಫಾಸ್ಟ್ ಆಗಿ magnet ನ coil ಹತ್ರ ತಗೊಂಡು ಬರ್ತೀವಿ ಅಥವಾ coil ಇಂದ ದೂರ ತಗೊಂಡು ಹೋಗ್ತೀವಿ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. So that is the third point, right? So this is about the coil and magnet experiment. So very important. So ಇದು ಮೊನ್ನೆ ಸಪ್ಲಿಮೆಂಟರಿ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೂಡ ಇದನ್ನ ಕೇಳಿದ್ದಾರೆ, right? So move on to the next. Explain the working of transformer and the principle of transformer, right? So transformer is a device, right? So question number 1. Transformer is a device which is used to increase or decrease the AC voltage. So on what principle the transformer is working? So transformer is working on the principle that is mutual inductance, right? So what is mutual inductance? So mutual inductance or mutual induction. So mutual induction is the phenomenon in which the EMF is induced or current is induced in the neighboring coil when the current is flowing in another coil. So ಬೇರೆ coil ಅಲ್ಲಿ current flow ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ, so there is a change in flux. Due to that change in flux, the EMF is induced in the neighboring coil. So ಹತ್ರದಲ್ಲಿರೋ coil ಅಲ್ಲಿ ನಮಗೆ EMF induce ಆಗುತ್ತೆ. So that is the principle of the mutual induction, right? So working of the transformer. So transformer consists of a core, right? So onto this core, so the wire are wounded. So this becomes the coil. So this coil is subjected to AC voltage, right? So it has two coil, is output, right? So the first written as this coil as the primary coil. So this one is the secondary coil, right? So here input AC voltage, right? So when current is flowing in the primary coil, right? So when current is flowing in the primary coil, then it induces the flux, right? So current flow of the coil it produces the flux, that is the EMF. So it produces the EMF. Due to that EMF is linked with the secondary coil. So that is the nearby coil, right? So that is explained by the mutual induction. So mutual induction phenomenon ಅದು ಒಂದು coil ಅಲ್ಲಿ current flow ಆಗ್ತಾ ಇದ್ರೆ EMF induce ಆಗುತ್ತೆ neighboring coil ಅಲ್ಲಿ, right? So that is the principle of the transformer, right? So work ಆಗೋದು ಯಾವಾಗ ಅಂದ್ರೆ when the primary coil is connected to the AC source, then the current is flowing in the primary coil. So EMF is induced in the primary coil. So this EMF is linked with the secondary coil. So secondary coil nearby irodinda, so illi produce agtiro flux which is linked with the secondary coil. So hence EMF is induced across the secondary coil. That means here we are getting the output voltage, right? So the voltage, that is EMF, is nothing but the voltage. So output voltage we are getting, that depends on the EMF, voltage or EMF, which depends on the number of turns in the primary coil and the number of turns in the secondary coil, and also the input voltage. So on all these factors, the output we are getting, that depends on the number of turns in the primary coil and number of turns in the secondary coil, and also the input voltage, right? So ನಮಗೆ output voltage ಸಿಗ್ತಾ ಇದೆ. ಸೊ ಅದು ಯಾವುದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ ಅಂದ್ರೆ number of coils N1, that is first coil ಅಲ್ಲಿ, then the number of turns in the second coil, and also the input voltage, right? So this is the working of the transformer, right? So along with this, Vs divided by Vp, that is equals to Ns divided by Np, right? So where N1 into Np, that is primary coil, Ns secondary coil, right? So P is the voltage across the primary coil, and Vs is the voltage across the secondary coil. We need the voltage across the secondary coil, right? So Vs is equals to Ns by Np into Vp. So So the voltage across the secondary coil depends on number of turns in the secondary coil, number of turns in the primary coil, and the voltage which we are applied across the primary coil. Right? ತುಂಬಾ lengthy explanation ಇಲ್ಲ, only few lines ಇದೆ ಅಷ್ಟೇ. So transformer consists of a core. So two coils are wounded on the two arms of the core. So first coil is considered as a primary coil and the second coil is considered as the secondary coil, right? For the primary coil, so applying the input voltage, so current is flowing in the coil, so EMF is induced. So this induced EMF is linked with the secondary coil, so hence we getting the current output or voltage output. So ಇಲ್ಲಿ ನಾವು current ಆದ್ರೂ output ಆಗಿ ತಗೋಬಹುದು ಅಥವಾ voltage ಆದ್ರೂ output ಆಗಿ ತಗೋಬಹುದು. So here we get the induced EMF in the secondary coil because of the current flowing in the primary coil. So that will be explained by the mutual induction. So mutual induction phenomenon ಇಲ್ಲಿ transformer ಅಲ್ಲಿ ಕೂಡ ನಾವು apply ಮಾಡ್ಕೊಂತೀವಿ, right? So the output voltage depends on, so we are getting the output voltage. So this output voltage is depends on the number of turns in the primary coil, number of turns in the secondary coil, and the voltage which we are applied for the input, right? So this is about the working of the transformer, right? So move on to the next question. 21st question, mention any three applications of eddy current. So ಇದನ್ನ 2 marks ಅಲ್ಲಿ ಕೂಡ ನಾನು ಹೇಳಿದೆ, right? So applications of the eddy current is, so braking system, so induction furnace. Next, the third one is the electromagnetic damping, right? So and the last one is power meters, right? So that is electric power meters. So then we are using the eddy current, that is, so already ಅದು repeat ಆಗಿದೆ 21st question. So 2 marks ಅಲ್ಲಿ. Move on to the next question, that is 22nd question, right? So mention any three applications of total internal reflection. So applications of total internal reflection, so one is the optical fiber, so the second diamond, and the third one is totally reflecting prisms. So where we are using those totally reflecting prisms, that is in binoculars, telescopes, and also in periscopes, and also one natural phenomenon, that is the mirage, right? So these are the applications of total internal reflection, right? So 22nd question, total internal reflection application. So in that first one is optic fiber. So the phenomenon of total internal reflection we are going to use in the optic fiber and totally reflecting prisms. So these totally reflecting prisms we used in binoculars, telescope, and periscopes, right? So the next one is mirage. So this one is the natural phenomenon, is brilliant diamond. So these are the applications of total internal reflection, right? So next, define critical angle. Write two conditions for total internal reflection. So for any given pair of media, so critical angle is defined as the angle of incidence in a denser medium is equals to the angle of refraction, that is 90 degree. For any angle of incidence in a denser medium, the angle of refraction is equals to 90 degree. So that we call as the critical angle, right? So two conditions for total internal reflection means the light should travel from the denser medium to rarer medium, and the second one is the angle of incidence must be greater than the critical angle. So those are the two conditions for total internal reflection, right? angle for a pair of media is defined as for the angle of incidence in denser medium for the angle of incidence in denser medium angle of refraction is 90 degree, right? So that is the definition of the critical angle. So the angle of represent two medium, that is rarer and another one is denser, right? So when the ray of light, this is the critical angle, so this is the angle of refraction, or that is equals to 90 degree, right? So conditions. So in the first one, light should travel from denser medium to rarer medium. The second one is angle of incidence is greater than critical angle, right? So these are the two conditions for total internal reflection. Conditions for total internal reflection, right? So next, derive the expression for effective focal length of two lenses in contact, right? So that is 24th question. So sometimes they ask this question for 5 marks also, right? So consider two thin length A and B which are placed in contact, which having the focal length f1 and f2. So consider two thin lenses A and B having the focal length f1 and f2, right? So this is the principal axis. So who is the object when the ray of light which is incident on the first lens, it forms the image at I1, right? So this I1 acts as the virtual object for the second lens, right? So first image form ಆಗಿರುತ್ತೆ, that is D2 because of the lens A, right? So this image acts as a virtual object for the second lens B, right? So this becomes the incident ray. Then finally we are getting the image I, so which is at a distance B. So image distance always be taken B, the object distance be taken U. So first this be taken V1, right? So ಎಲ್ಲ ಕಡೆಗೂ ನಮಗೆ ray diagrams ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಮಾಡೋದ್ರಿಂದ ಎಲ್ಲ ಕಡೆಗೂ arrow marks ಇರಬೇಕು. So very important, right? So the first point is image formed by lens A, right? So that is the lens formula use ಮಾಡಬೇಕು. So explanation ಏನಿದೆ ಅಂದ್ರೆ consider two lenses A and B having the focal length f1 and f2 respectively, right? So is to explanation ಅಲ್ಲಿ ಇರಬೇಕು ಅಷ್ಟೇ, right? So one line ಬರುತ್ತೆ, so one line ಬರ್ಸ್ಬಿಟ್ಟು next the image formed by lens A. So image ಎಲ್ಲಿ ಫಾರ್ಮ್ ಆಗ್ತಾ ಇದೆ ನಮಗೆ I1 ಹತ್ರ ಫಾರ್ಮ್ ಆಗ್ತಾ ಇದೆ, right? So that is by the formula, right? So mirror formula, that is minus 1 by u plus 1 by v1, that is equals to 1 by f1. So why minus? Because so incident ray ಗೆ opposite ಆಗಿ ನಾವು distance ನ ಮೆಜರ್ ಮಾಡ್ತಾ ಇದೀವಿ, so hence we taken minus u. So ಇಲ್ಲಿ plus v1 ಏನಕ್ಕೆ ಅಂದ್ರೆ in the direction of incident ray ಅಲ್ಲಿ ನಾವು distance ನ ಮೆಜರ್ ಮಾಡ್ತೀವಿ, hence we taken plus v1, right? So calling this as the first relation, right? So the next one is the image formed by the lens B, right? So for the lens B, so second lens game, I1 acts as the object and I acts as the image, right? So I1 by V1 represents the, that is 1 by V1. So I1 is the object, V1 is the object distance, so I is the image and V is the image distance, right? So that is the virtual, right? So that is minus 1 by V1, right? So incident ray ಈ ಕಡೆ ಬರ್ತಾ ಇದೆ, so opposite direction ಅಲ್ಲಿ ಮೆಜರ್ ಮಾಡ್ತಾ ಇರೋದ್ರಿಂದ, so that is V1, right? So plus, so this one is the object distance, so now the image distance is V1, so in the direction ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ 1 by V, right? So 1 by V, that is equals to 1 by F. So calling this one as the second equation. So adding the equation 1 and 2, add equation 1 and 2. So that is minus 1 by U plus 1 by V1 minus 1 by V1 plus 1 by V, that is equals to 1 by F1 plus 1 by F2. Right? So plus 1 by V1 minus 1 by V1 get cancelled. So this we can write 1 by V minus 1 by U, that is equals to 1 by F1 plus 1 by F2. Right? So third equation. Now the combination of lenses is replaced by a single length of focal length F. So ಎರಡು combination length ಏನಿದೆ ಅದನ್ನ replace ಮಾಡ್ತಾ ಇದೀವಿ only by the single lens, that is the effective length ಅಥವಾ effective focal length, right? So similar capacitance ಅಲ್ಲಿ ನಾವು ಯಾವ ತರ equate ಮಾಡ್ಕೊಂಡಿದ್ವು ಅದೇ ತರನೇ ಇಲ್ಲಿ, so ಅಲ್ಲಿ two capacitors which are connected in series parallel discuss ಮಾಡಿದ್ವಿ. So same wise here also two lenses which are connected in contact, so ಎರಡು ಜೊತೆಗೆ ಇರೋದ್ರಿಂದ ಇದನ್ನ ನಾವು ರೀಪ್ಲೇಸ್ ಮಾಡಿ ಸಿಂಗಲ್ ಲೆಂತ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿದ್ವಿ. ಸೊ ಸಿಂಗಲ್ ಲೆಂತ್ ಎಫೆಕ್ಟಿವ್ ಗೆ ಎಫ್ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ದಟ್ ಬಿಕಮ್ಸ್, ಸೊ ರೀಪ್ಲೇಸ್ ದ ಕಾಂಬಿನೇಷನ್ by a single lens having focal length F, right? So ಅದಕ್ಕೆ ಮತ್ತೆ ಡಯಾಗ್ರಾಮ್ ಏನು ನೆಸೆಸರಿ ಇಲ್ಲ, ಸೊ ಇದು ಒಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಬರ್ಬಿಟ್ಟು, so the length formula 1 by V minus 1 by U, that is equals to 1 by F, right? So take on that one as the equation 4, right? So from equation 3 and 4, so LHS ಅಲ್ಲಿ 1 by V minus 1 by U ಇದೆ, ಇಲ್ಲಿ ಕೂಡ 1 by V minus 1 by U ಇದೆ. So from equation 3 and 4, so we can write 1 by F, that is equals to 1 by F1 plus 1 by F2, right? So that is the derivation to find two thin lenses which are in contact, right? So diagram ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. So without diagram ನೀವೇನೇ ಬರೋದ್ರೂ ಅದಕ್ಕೆ ಯಾವುದೇ ತರದ ಮೀನಿಂಗ್ ಇರಲ್ಲ, right? So why? Because the image formed by lens A ಅಂತ ಇರುತ್ತೆ, ಇಲ್ಲಿ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ನಿಮಗೆ ಯಾವುದೇ ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ಅಲ್ಲಿಗೆ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಗೆ ಮೀನಿಂಗ್ ಇರೋಲ್ಲ, ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಯಾವುದೇ ತರದ್ದು ಮಾರ್ಕ್ಸ್ ಸಿಗೋದಿಲ್ಲ, ರೈಟ್? ಸೊ ಮೂವ್ ಆನ್ ಟು ದ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. ಎಕ್ಸ್ಪ್ಲೈನ್ ದ double slit experiment, right? So in double slit experiment means slits consist of two small slits, right? So from the slits the light will interfere, so equal distances ಇರೋದ್ರಿಂದ point source ಇಂದ so interfere ಆಗುತ್ತೆ. So there we are getting the constructive and destructive patterns, right? So next 26th question, what is interference? Write the condition for the path difference in case of constructive and destructive interference, right? So that is the modification in the redistribution of the light energy, right? So that is the interference, right? So what is the interference? So interference is the modification in the distribution of light energy when two or more light superpose. So one light waves ಮೇಲೆ another light waves overlap ಆದಾಗ ನಮಗೆ ಪ್ಯಾಟರ್ನ್ ಸಿಗುತ್ತೆ. ಸೊ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ? ಇಂಟರ್ಫರೆನ್ಸ್ ಅಂತ ಕರಿತೀವಿ, ರೈಟ್? ಸೊ ವಾಟ್ ಈಸ್ ಇಂಟರ್ಫರೆನ್ಸ್? ಸೊ ಇಂಟರ್ಫರೆನ್ಸ್ ಈಸ್ ದ modification in the redistribution of light energy when two or more light waves superpose, right? So that is the definition for the interference, right? So condition for the interference. So now exam ಮುಂದೆ ರಿವಿಷನ್ ಅಲ್ಲಿ ಕೂಡ ಕಂಡೀಷನ್ಸ್ ನ ಹೇಳಿದೆ ಅಂದ್ರೂ ಕೂಡ ಯಾರು ಪ್ರಾಪರ್ ಆಗಿ ಬರ್ದಿಲ್ಲ ಕಂಡೀಷನ್ಸ್, ರೈಟ್? ಸೊ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಪಾರ್ಟ್ ಡಿಫರೆನ್ಸ್ ಮತ್ತೆ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಸಿಂಪಲ್ ಇದೆ, ಬಟ್ ಏನೇನೋ ಬರ್ದಿದ್ದೀರಾ, ರೈಟ್? So that is question number 26. It is modification in the distribution of light energy when two or more light waves superpose each other. So this is the definition of the interference, right? So conditions. So conditions for the interference. So interference only two types work. One is constructive interference and another one is destructive interference, right? So first one is constructive, right? So constructive interference. So condition for the constructive interference. So constructive interference only again we discuss this constructive interference in two mediums. That is, one is in path difference and another one is phase difference. So in that first one is path difference. So in terms of path difference, that is equals to n lambda, right? So path difference only n lambda, the same in phase difference, that is equals to 2n pi, right? So lambda is replaced by 2 pi, right? So n lambda is lambda hatra 2 pi na replace ಮಾಡಬೇಕು ಅಷ್ಟೇ, right? So the next one is for the diffractive interference, right? So in that again in terms of path difference. So path difference only n plus 1 by 2 into lambda, right? So ಇಲ್ಲಿ n ಇದೆ, ಇಲ್ಲಿ n plus 1 by 2 into lambda ಬರುತ್ತೆ. The same in terms of phase difference, right? So that is again n plus 1 by 2 keeping as is. So in place of lambda you need to substitute with 2 pi. So ಇಷ್ಟ. So but exam ಅಲ್ಲಿ ಏನು ಬೇಕೋ ಅದನ್ನ ಬರೋದಿಲ್ಲ, right? So simple ಇದೆ. Path difference ನೆನಪಿತ್ತು ಅಂದ್ರೆ easily you can write the phase difference, right? So constructive ಗೆ n pi ಇರುತ್ತೆ, destructive ಗೆ n plus 1 by 2 ಇರುತ್ತೆ, right? So next, write the three differences between the interference and diffraction, right? So ಎರಡರದ್ದು ಡೆಫಿನೇಷನ್ಸ್ ಬರೀಬೇಕು, ಇಂಟರ್ಫರೆನ್ಸ್ ಮತ್ತೆ ಡಿಫ್ರಾಕ್ಷನ್. Then question number 27. Interference and diffraction, right? So the first point is interference fringes are of equal width. So either it may be dark band ಇರಬಹುದು ಅಥವಾ bright band ಇರಬಹುದು, ಎರಡು ಕೂಡ ನಮಗೆ ಸೇಮ್ width ಇರುತ್ತೆ, right? So but diffraction fringes of unequal width. So center ಇಂದ ಮೂವ್ ಆಗ್ತಾ ಹೋದಂಗೆಲ್ಲ ಅದ್ರದ್ದು width ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ ನಮಗೆ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, right? The second point is intensity of right. So intensity ಕೂಡ ಏನಿರುತ್ತೆ ಎಲ್ಲ ಬ್ರೈಟ್ ಫ್ರಿಂಜಸ್ ಸೇಮ್ ಇರುತ್ತೆ, right? So here intensity of bright fringes varies. So ಅವಾಗ ಹೇಳಿದಂಗೆ ಫ್ರಮ್ ದ ಸೆಂಟರ್ ಇಂದ ಮೂವ್ ಆಗ್ತಾ ಹೋದಂಗೆಲ್ಲ ವಿಡ್ತ್ ಇಂಟೆನ್ಸಿಟಿ ಕೂಡ ಫ್ರಿಂಜಸ್ ಇಂಟೆನ್ಸಿಟಿ ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಡಿಮ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, right? So that is the second point, depend on the intensity. So on the third point is the intensity distribution curve. So intensity distribution curve in case of the interference, right? So ಈ ತರ ಪ್ಯಾಟರ್ನ್ ಇರುತ್ತೆ, that means all having the same intensity. So ಎಲ್ಲವೂ ಕೂಡ ನಮಗೆ intensity ಏನಿರುತ್ತೆ ನಮಗೆ ಸೇಮ್ ಇರುತ್ತೆ, but here in diffraction pattern ಸೆಂಟರ್ ಅಲ್ಲಿ ಮಾತ್ರ ನಮಗೆ ಬ್ರೈಟ್ ಇರುತ್ತೆ, ಆಮೇಲೆ ಹೋಗ್ತಾ ಡಿಮ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, like this. So these are the 3 points. So ಈ 3 points ಜೊತೆಗೆ in case 5 marks ಗೆ ಕೇಳಿದ್ರು ಅಂದ್ರೆ definitions. So interference definition, diffraction definition. So ಎರಡರದ್ದು definition ಮತ್ತೆ ಎರಡರದ್ದು constructive interference ಗೆ condition, ಈ ಕಡೆಗೂ ಕೂಡ constructive diffraction ಗೆ condition. So ಎರಡರದ್ದು in terms of part difference ಅಲ್ಲೂ ಬರೀರಿ ಅಥವಾ in terms of phase difference ಅಲ್ಲೂ mention ಮಾಡಿ, right? So remaining questions we will discuss in our next class, right? Thank you.